Hello meteorology students, Dr. Schrage here, and I want to demonstrate how you use Newton's method to solve for the roots of an equation, and you can do this in Excel. Remember, we were doing it before in our Pencast, and it was a little bit tedious. There was just too many steps, too many places you could make a mistake doing it on paper. So let's try to do this in Excel. Now, I have a spreadsheet. It's called Teaching About Newton's Method in ATS 570, and it'll be available to you on Blue Line, which will be helpful to you as well. I want you to notice, though, okay, so here's our first problem. We're going to be finding the root or zero of the following function, g of x equals sine of x. Okay, not a very complicated example at all. I wanted to keep it as simple as possible on our first one. And we're going to be looking for a graph of that function, and we're going to look for the root that is somewhere near 3. Well, you know darn good and well what the answer is. The answer is going to be pi. But let's see if we can actually get this done using a Newton's method problem. So, again, this is assuming that you have seen the presentation already about Newton's method. I'm going to be making a little table here where, like, for example, on my n, my first guess is equal to 1. Let me see here. Is there a way to make this whole screen bigger for you? I don't think there is. Let's see here. View, zoom. Let's go like 150, maybe even 200%. Why not? See if that helps. Okay, that might make it a little easier for you to read. All right, so over here, I've got my first guess is, for guess number 1, I said that we're going to be looking for it near 3. So our guess nx of 1 is 3. Okay, g of x, our function was just right here, it's sine of x. G of x is the sine of x. So equals the sine of, hey, let's be more clear about this. Anytime you're into a formula in Excel, you start with the equal sign. And then whatever equation you're entering. Like in this case, it's the sine of. Now, how do I say the sine of xn? I use my arrow keys, would be the easiest way to do this, and drive over to, see how it's highlighting now that cell that's next to me, and it actually says in there equals sine of F32. All right, that is what I want. I want equal sine of F32. I put the close parentheses in there and hit enter, and it'll fill it in that is the sine of F32. And notice over here, if I go and look at the equation bar, the formula bar in the terminology of Excel, it tells us that this equation is equals sine F32. All right, now g prime of xn. G prime, if g is sine of x, then g prime is cosine of x. So this equation right here will be equals the cosine of, now we need of that xn again. So we're going to go back over here, drive over to there. You can see how we're highlighting the cell, and you can see how the equation here is equals cosine of F32. Put the closed parentheses in there and hit enter, and you get that. Okay, now again, assuming that you have seen the presentation, the Pencasts about how Newton's method works, you know that the equation for x of n plus 1 is x of n minus the quantity g of xn divided by g prime of xn. So we're going to just do that. Equals x of n minus g of xn divided by g prime of xn. See how I just filled in all those equations there? And we get the first value. All right, cool. That is our guess 2. By the way, we know that the answer is going to be pi, 3.14159. You can see we're practically there already. This is a very well-behaved function. It didn't really take very many steps to make this thing work. All right, now I'm going to show you a nifty little standard trick in Excel. Okay, so yes, we could sit here and type 2, 3, 4 like this, but I mean, we don't know in advance how many of those we need. I mean, if you needed 1,000 entries in this table here, that would get a long time. If we just make this formula equals this cell, see, I went up with my arrow key, highlighted that cell, plus 1. That's going to be equal to 2. Now, I know that seems like a lot of work, but when you copy that down 10 rows, you've saved yourself all the steps of typing in all those numbers. All right, what is x sub 2? Well, it is actually just this value right here, right? It is x of n plus 1 when n was equal to 1. So we're just going to say this is equal to this cell right here. That's just all our equation is. All right. That is our new value, x of 2. Now we need g of x2 and g prime of x2 and this new value here. We need these 3 cells. Now, if you're sitting there re-entering those same equations over and over again, you're doing something wrong. Because what we really want to do is highlight these 3 cells, which can be done with your mouse, or it can be done, I just did it by driving onto the first one with the arrow keys, holding down the shift key and using the arrow keys to highlight the other ones. Probably the mouse is more intuitive if you're not, you know, a spreadsheet pro. And then I'm going to hit copy. I would normally use a keyboard shortcut here, but I am going to do it with the menus just so it's a little more obvious what I'm doing. I'm going to copy those cells, and then I'm going to move my cursor down to where I want it to start, and I'm going to say paste. Look what actually happened here. We have, if we look at these equations now, like for example the one I'm parked on right now, equals sine of F33. See how in the previous cell said F32, sine of F32, now it says F33. This is what's called a relative reference in Excel. We have, as we copy the equation down, it just keeps pointing to relative to it, like one cell over. So since this equation here was sine of F32, where F32 was one cell to the left, when I copy that equation down, it says F33. Similarly, like this cell right here, it says cosine of F32. That's two cells over to the left. When I copy it down, it'll just make it two cells over to the right. Sorry, it's two cells over to the left. All right, this is our new guess of x1. Now look what I can do. Now that we have a set of these equations up here, I can actually choose this whole line here, copy it, and feel free to paste it a whole bunch of times. And look, now we have up to 9 guesses here. Although you can see it actually by the third guess, we have 3.14159, and it probably has more digits than are fitting on the screen because it looks like it takes until the fourth guess before g of x of 4 is such a tiny number. It's times 10 to the negative 16th. So in this case, our answer is unsurprisingly 3.14159. This is our value for the root of g is equal to the, where are we at here? G is equal to the sine of x, which is this equation, this graph right here. X equals 3.14159 is the value, it is a root of the equation. It gives you a value of 0. Okay, all right, I want to show you 2 more examples in the coming slides, 2 more short videos that help you see what's going on here.